Welcome back to the Explainer. So, you've made it to the 12th rung of our LogicLadder Roadmap, and honestly, this is a massive transition point. Up until now, we've spent a lot of time figuring out how a computer thinks and searches using local logic. But today we're shifting gears. We're moving from how a computer processes information temporarily to how it permanently remembers information at a massive scale. We are finally diving into the world of databases. Okay, let's kick things off with what I call the memory wipe problem. Think back to rung 3 of our roadmap, where we first started using variables like username or a player's score. What actually happens to your follower count or your chat history the exact second you turn off your phone or close the app? Well, if we only rely on those standard C++ variables, that data is completely gone, wiped. So how on earth do modern apps actually remember who you are days, months, or even years later? To answer that, we have to look at the stark contrast between these two environments. On one side, we've got volatile memory, or RAM. This is where our code's variables live, but only while the app is actively running. It's incredibly fast, sure, but it forgets absolutely everything the second the power cuts. On the other side, we have persistent storage, which is your disk. This is the permanent home of databases. So today, we are officially graduating from writing code that just thinks in RAM to building robust systems that remember millions of records on disk. To really wrap our heads around this shift, let's move to our next section, the analogy, the drawer versus the warehouse.
Think of local logic, a standard variable in your code, as just a single drawer in your personal desk. It's right there, it's super fast to open, but you only have a few drawers, right? Its capacity is tiny. A database, which represents global logic, is fundamentally different. It's not a drawer. It's a sprawling, massive global warehouse. It has millions of rows of shelving, and the biggest difference? This warehouse is shared by every single user interacting with the app at the exact same time.
So the takeaway here is that this digital filing cabinet is literally the backbone powering all your favorite software. When you're scrolling through your Instagram post history or when Netflix fires up your personalized recommendation engine, you aren't just looking at a screen. You are interacting with a massive, highly organized database that manages millions of user records simultaneously without breaking a sweat.
Now let's move right along to section breaking down the language. What is SQL?
Obviously, if you're standing in a warehouse with millions of shelves, you don't just start walking down the aisles hoping to find what you need. To avoid total cognitive overload, I want you to think of SQL, which stands for Structured Query Language, as our dedicated warehouse manager. Instead of searching manually, we just hand the manager a request, something like, hey, find me every user who joined in 2026. SQL uses a super strict catalog system to do this instantly, organizing data into rows, which are individual records like a single user, and columns, which are the specific attributes of that user, like their age or email.
Let's actually see this in action. Welcome to section Live Demo, your first query.
Here is a beautifully clean look at what we'll call the warehouse aisle. This is a standard database table designed to store social media posts. Check out the columns at the top. We have a specific user ID and the actual post text. And right below that, we've got our rows of data for different users, like user 101 and user 102.
And here is the basic SQL command we'd use to ask our manager to fetch data from that exact aisle. We simply tell it, select the post text from the post table where the user ID is 101. It honestly reads almost exactly like plain English, doesn't it? Let's actually zoom right in on step 3, the where clause. This right here is the absolute game changer. This is the vital filter that stops our manager from backing up a truck and bringing us the entire warehouse inventory. Without this filter, we try to download millions of posts all at once, and our app would crash immediately. The where clause guarantees we only pull the exact item we requested.
All right, now that you know how to fetch data, we have to tackle a real-world professional hurdle. Let's look at section Growth Mindset, the null value mystery.
Think about this scenario for a second. What happens if our warehouse manager goes to grab a required attribute? Say they're looking for a user's email address column. But when they check the shelf, it is completely 100% bare? The data was just never collected. Bam! You get hit with an intentional error just like this. A null value is basically a developer's term for an empty void where data was supposed to be. And if your code isn't prepared to handle a bare shelf, encountering a null value will literally crash your entire application on the spot. Which brings us to a huge lesson in problem solving. In professional engineering, you have to design systems for reality, not some perfect, error-free world. You have to expect the unexpected. This means you need to write code that handles these empty, null variables gracefully, without crashing the whole system. Learning how to read those error messages, isolate the exact line of code causing the issue, and debug it, that is exactly how you build resilience. Handling missing data builds the specific logical problem-solving muscle you need to land those 10 to 15 lakh per annum software engineering roles we're targeting on this roadmap. You can absolutely do this.
As we wrap up this explainer, I want to leave you with a provocative question to chew on before our next step. If a database is tasked with permanently remembering millions or maybe even billions of records, how exactly do you design that warehouse so that retrieving one specific memory takes less than a single second? Think about the mechanics behind that kind of speed. Keep exploring, keep building, and I'll see you in the next explainer.